Good day, good people. In this video, I'm going to build a full stack paging solution. I will demonstrate how to use mock data to populate a database using a Visual Studio database project and Microsoft SQL Server. I will create a REST API to access the data using .NET Core and ADO.NET. I will test the API in Postman, and then I will show you how to take some static HTML from the Bootstrap site and use it to create a custom pager control from scratch in Angular 7. I will also involve the Angular router in the paging process so that you can take a URL and share it with somebody, and so that you would not lose your place if you, say, refresh the page. So here's what we'll be building. This custom pager control can control any list of items. It doesn't necessarily have to be in a table format. And then we'll involve the router so you can share the link, and the app will initialize on page 17 with a page size of 10, or you can change the page size to something different. Okay, so this is a fair amount of code, so I will be talking and pasting chunks of code as I go to save time in the video. If you find this interesting, you can download the source code and do whatever you want to with it from my GitHub page. Okay, here is the structure of the project that we will create. Generally what I do when I build something like this is I start with by adding a solution, and then I will add the database project to this solution just to keep it simple. And we'll have a project for data access, we'll have a models class library, and then we'll have a .NET Core web solution with a Angular client. So I'm going to show you how to get started by adding the solution. So you go File, New, Project, and then down here at the bottom of all these options, there's other project types, and you just say Visual Studio Solutions. We'll go ahead and give it a location, and we will name the solution Full Stack Paging. Go ahead and add that. So now that we have that, we'll go ahead and add a new project to the solution, project, and we'll come find SQL Server and SQL Server Database Project. Now what this allows you to do is basically just keep your code in a place that can be checked into source control. You can't do that with SQL Server Management Studio. So this is a really nice way to manage your SQL code. So we'll name this project Pager Data. All right, now that we have that, I'm going to show you how to go out and get some mock data from a site called Mockaroo. Okay, so here we are at Mockaroo. I think this is a great site because you can configure all kinds of static testing data that you need. And what I generally do is, you can select all these formats, but I'll select SQL and I'll say include create table. You'll have to log in to download what you need, but the preview will look like this. So I'll basically take the create table SQL code and all these insert statements and put them into the database project. And just to show you, in SQL Server, I have created a sample database called Paging Demo, and we're going to go ahead and use the database project to scaffold up the data and publish it into this database. All right, so I'm going to come back over into my database project, and I'm going to add a new table. I'm going to call that create mock, or create table mock data. And I'll go ahead and paste in the SQL code from Mockaroo. Then I'm going to go ahead and add a script. I'll just call that add data. And into the script, I will paste all of the insert statements that I got off the Mockaroo site. All right, so to implement paging in SQL code and a store procedure, we're going to go ahead and use the offset fetch next clause. The offset fetch next clause, which is used in conjunction with an order by clause. So we're going to take a snippet like this and convert it into a store procedure. So back over here in our database project, we'll just go ahead and say add store procedure, and we'll call this get paged data. And I will go ahead and paste my store procedure in this. So basically this guy's going to take a skip and a take count, And this SQL code will select the ID, the first name, last name, etc. from our mock data table, order it by the first name and last name, and then basically page through that set of data and return what you are asking for based on the skip and the take variables. The other thing we need to know to implement paging is the count from the table. So we're going to add one more stored procedure called get mock data count. So we'll add that. We'll go ahead and add this simple select count from dbo.mockdata. All right, we can go ahead and build this to make sure we don't have any errors, and that looks good. So the next step is to go ahead and publish this into our SQL Server database. So to publish into your local database, you simply click on the database project and say publish. You'll want to load the profile you created, which is like your connection strings and stuff for your local SQL Server. I'm using a local SQL Server, so it should just be like localhost and whatever you named it. Go ahead and open that up and hit publish, and this will just go ahead and push the procs and the scripts into the database, which will actually populate the data as well. Okay, so now that's successful, we can go over to our SQL Server and find our table, click, select top 1,000 rows, and we now have mock data. And just to be diligent and test it real quick, we will come back over here, grab the name of our proc, dbo, usp, get page data, come back over to SQL Server, and use the execute command to test the proc. So we're just going to get first page and 10. And we'll go ahead and highlight it and execute. Okay, so there's our first 10 records. We can see if we move to say like page 50, if it might be 50 pages, but as we're actually still in the A's. So that works, that's good to go. Next, we'll move back over into Visual Studio and scaffold up our class libraries for accessing the store procedures and our class library for data transfer. Okay, so back over in Visual Studio, we're going to go ahead and add our data access library and our models library. So C#, .NET Core, class library, .NET Core, we'll just call this data access. Go ahead and delete this class it adds by default. We'll add one more called models. And delete the default class there as well. And last but not least, we'll go ahead and add our .NET Core Web API solution. So .NET Core Web ASP.NET Core Web Application, and we'll just call that paging. It's going to bring up some defaults. I'll just select API, and we'll go ahead and just uncheck configure for HTTPS since this is just a demo. Okay, now that we have all our projects set up, we can go ahead and add a few classes to our models project. These classes are essentially for transferring data from the server to the client, so they'll be fairly simple. Okay, so I've added a class for the mock data DTO. I've added a class for a page, which is essentially going to be the request we make coming from the client that the .NET Core API will deserialize. I've added a class for a page list, and within that class, I will just inherit from a list of T and then add a special property to that so we can kind of manage transferring that metadata around between the APIs. And then the page list metadata, which will represent like the current page count and the skip and the take and stuff like that. Okay, in our mock data DTO, we just need to add a class that represents a record from the mock data database. The page class is just going to be a simple data transfer class with a page number and a page size, which will come as a request from the client side. In the page list class, we're going to go ahead and inherit from list of T. And this is just so we can add a little bit of custom metadata as we are dealing with a list of items. And since we're going to use our page metadata in this class, I'm going to go ahead and scaffold up the page list metadata class as well. So, whoops. Okay, this class represents the metadata about our current paging operation, and what we're going to do is we're going to serialize serialize this guy into a custom header to ship that down to the client, and vice versa as the client sends the page class back to the server in a request. Okay, so back over in our page list, we're going to add a public property that is the page list metadata. And we will add a constructor where we create an instance of the page list metadata that will take the incoming page number and the page size, figure out what the skip and the take count is to pass to the stored procedure, and figure out like the total pages here. This line of code will properly chunk the current page chunk with the incoming constructor parameters. All right, we'll go ahead and build. Everything looks good so far. So now that all our models are created, we can come to our data access project and create our data access layer. So the first thing I'm going to do is create an interface for our data access API so we can use out-of-the-box dependency injection with .NET Core. And what that allows you to do is essentially just swap out whatever dependency your controller is using for a different one in the case you want to test something. Okay, so I've added an interface and a mock data class which will implement the interface. So I'll go ahead and come over here, add two operations, one of which will be a get the mock data count. Go ahead and add the page list. Let's see. We need to add a reference to our models project, so we'll just say, let's see, add reference. Go ahead and select models, add it. And then here we can use IntelliSense to figure out what we need. All right, that looks good. Go ahead and build one more time, make sure everything is running. Okay. Now we can come into our implementation class. We'll go ahead and make this guy public. And data, and we'll use Visual Studio IntelliSense to go ahead and scaffold up the interface methods. Since these are tasks, we'll go ahead and add the async keyword to each of them. And before we can actually implement these methods, we actually need to add our connection information to our database. And normally you'd want to add this information in a configuration file or something, but for the purposes of this demo, I'm just going to add it in this class to keep it simple. So there's my connection string to my local data source. And next I will add a method to go ahead and get me a SQL connection. Go ahead and add references to system.data.SQL client. All right, now that we have that, we can finish filling out our method implementations for get mock data. This is standard ADO.NET code. All you need to do is create a SQL connection, create a SQL command, and denote the type of the name of the stored procedure you want to access. This is just a straight up data connection. There's no ORM layer or anything, so this is just a quick, easy way to connect to the database and access a stored procedure. Next, I will fill out the get mock data paged implementation. So basically, this is going to take the page parameter coming from the client side. It's going to go ahead and create a paged list for us with a mock data DTO generic parameter. We'll go ahead and create our SQL connection, create a SQL command, and denote the stored procedure we want to access. We'll call the reader using the async version of the method, and we will generate an instance of our mock data DTO object for each item in the returned list. All right, we'll go ahead and build one time to make sure everything looks good. Everything looks good, so now we can head over to our paging server, .NET Core server-side project and implement the controller for our API. So I'm just going to go ahead and rename values controller to data controller. This guy up. So yes, please rename that for me. And what I like to do is I'll go ahead and just say data here. So in the event we want to rename the controller or something, you don't lose the routing information about the API. So I'll just go ahead and get rid of all these default endpoints. I will go ahead and add a constructor, ctor tab. That'll add a constructor for us. And before we can do anything in this controller, we actually need to configure the dependency injection in the startup class in .NET Core. So we'll come over here. I will make sure I have a reference to my models project and my data access project. So come into dependencies, just say add reference, and we'll just say models and data access. Then in the configure services method, we can just go ahead and say add scoped to let .NET Core knows that it can inject an instance of the mock data class into a controller that requests it. So we'll go ahead and build one time, make sure we're good to go. Everything looks good, so we'll head back over to the controller. All we need to do over here is go ahead and use constructor injection to get at an instance of our mock data access layer. All right, so the next thing I'm going to do is go ahead and add my get endpoint for getting get mock data, and this guy is going to take and deserialize the URL parameter of the request into a page object. We'll just go ahead and add our references here. So what we'll do here is just go ahead and say page list equals await underscore mock data dot get data paged async, and we'll just go ahead and pass in the page. The next thing we need to do is go ahead and take the page list metadata that we get after we create an instance of our page list and stuff that into a custom response header. So we go response, headers, add, we'll just call it something like X pagination. We'll go ahead and say JSON convert. JSON convert dot, and we'll need to add Newtonsoft, which I think I forgot to do. Yep, there we go. JSON convert dot serialize object mock data dot page list metadata, and I'll go ahead and serialize that guy into the header of our response, and we'll just say return OK mock data. And when you're creating a REST API, it's good to use status codes in your responses so that consumers of your API can know if it was a good request, like if it was a 200 or if it was a bad request or access denied. So that's what action result and OK will do in your response. All right, so we'll go ahead and build and make sure. All right, we're looking good. So at this point, we have everything scaffolded up that we need. We have our models project, we have our data access project, we have our controller, which accesses our data access project. So the next thing I would generally do is use Postman to go ahead and call our API and make sure that it's working as we expect. All right, so I went ahead and set a breakpoint on our controller method here, and I'm going to come over here to Postman, where I have set up this URL, HTTP localhost, port number, API/data, page number equals 1, and page size equals 10, and we'll just go ahead and hit send to test the API. So over here, we see we hit our breakpoint. We have our deserialized page number or page object, which contains our page number and our page size. And I'll just go ahead and step into this guy real quick. So go ahead and get the count, configure all our SQL parameters, and as we can see, we're getting instances of our mock data DTO, and we should have 10 total. So yes, we have 10, and I'll let that continue through. And over in Postman, we can see we have this nice JSON result, and our custom header, X pagination, has been properly serialized into the response. All right, at this point, we have our server side and our back end configured and good to go, and we can begin building our front end using Angular 7. So the first thing I'm going to do is come over here to Commander and go into the directory where my .NET Core server project is, and run the ng-new command. So we'll say ng-new paging client, and we'll say minimal true because this is just for demo purposes. That will create the project without any testing frameworks. We'll want to have routing, and we'll have SCSS as our style option. Okay, I've scaffolded up our new project, and we can come back over to Visual Studio in our paging solution and see that we have now a paging client new Angular project. So since this is a single page application, by default, .NET Core has some middleware you can configure that will just tell it where to find the default files for a single page application. All right, so to send up the single page app, we just have to add two things, one of which is this. and you have to add right after use MVC app.use spa with whatever the name of the new project you created is. And we'll go ahead and use IntelliSense to add a reference to ASP.NET Core spa services. And we'll just go ahead and build, make sure everything looks good. All right, everything built okay. All right, so now we can go over and find this launch settings.json file, open that up, and just get rid of this launch URL. All right, so now that we've done that, we can go ahead and run the project. It should come right up. All right, so there's our new Angular client. And just to double check that everything's working, we can come over to the app.component.ts. And when I say everything, I mean hot module reloading, which is you just hit save and it refreshes with your latest changes. So, okay, that's good to go. So I'll just come over here and change it back real quick. Welcome. Page refreshes itself. All right, so the next thing I'm going to do is go ahead and move all this HTML out of the app component and separate it into a app.component.html, and I'll add an app.component.scss, and then I'm going to add 3 components, one of which will be a mock data component, one will be the mock data display component, and one will be our actual pager component. Okay, so I used the Angular CLI to scaffold up our 3 components. We have our pagination component, which is a smart component that can be hosted in some container component. And we have our mock data display component, which is the display component for our mock data component, which is essentially a container for these other 2 components. However, this pagination control can be used with any component and any list of data in any kind of form you want to create it in. All right, so the next thing I'm going to do, similar to what we did on the server, is I'm going to create a mock data class that represents the mock data objects that come from the server. I'm going to create a service to actually call the server, and I'm going to create a resolver service, which is a special type of service in Angular that allows you to get involved with what's happening in the routing, the state of the router before it actually renders a component. So in the event that you had no data or the page wasn't found or something, that you can direct or redirect the user to a page that tells them some message like that. Okay, I use the Angular CLI to scaffold up my mock data class, my mock data.service.ts, and my mock data resolver.service.ts. So first we can go ahead and fill out our mock data class. And this is basically the same thing that we had on the server side. So as we get the data back, we'll just create instances of our mock data class. All right, next we can come over to our mock data service. I'll go ahead and paste in the code for this service, which will essentially inject the HTTP client into the constructor of the service, and then use the HTTP client to call to pass the URL to the server side API/data with the page number and the page size. So we can actually inject this service into our components, and that's where we will be calling it from. I've also added this special object here that says observe response, so that we can wrap our mock data array in an HTTP response, so we can look at the actual status code if we wanted to. All right, the next thing we need to do is come over to our resolver service, and I'll go ahead and paste in this code. Oops, make sure I don't mess it up. Paste in this code, and essentially I'm going to inject our mock data service, the activated route, and the router into this guy. And what happens is when a navigation takes place, this will actually get called before a component is instantiated, and we can go ahead and call the service to make sure there is active data for the call. And if it does return data, we can go ahead and continue on into instantiating a component. And if it does not, we can navigate them to somewhere that does not exist, but you would have to create and add yourself. All right, so the next thing we need to do is go ahead over into our mock data component, which this is going to be sort of a smart component because it's going to manage making the request for the information from the server and delegating that down into the pagination component, which we will build in a few minutes. Okay, to begin filling out this class, I'm going to go ahead and take care of all my dependencies by using constructor injection to get them into this class. And we actually haven't created this guy yet. So next, some instance properties, one of which is going to be our mock data array. We'll also have a selected page property and a page metadata property. And since I haven't created these guys yet, we'll just go over to our pagination component and create these models for our page and our page metadata. All right, so I use the CLI to scaffold up a page in a page metadata class, so we can go ahead and use IntelliSense to fix up those references. Next thing we can do is take care of this pagination service. So I'll just uncomment this, and to talk about this for a minute, there's lots of different ways to establish component-to-component communication, but one of the ways you can do it is by using a shared service. So basically, the service can set up some sort of API that the component can expose to other components so that they can communicate with each other. Okay, so I went ahead and added the pagination service to the pagination components folder, and we can use IntelliSense to add that to our class. And coming over into the pagination service, we're actually going to expose the following API via this service. So we want to be able to pass the selected page around. We want to be able to set a page from query parameters, and we want to be able to reinitialize the component whenever we get a new set of data. So to do that, for each one of these guys, we set up a subject that takes a generic parameter, which in this case is a page. We set up a page source observable, and we say this.pageSource.asObservable, and then we can use this page, or we can subscribe to this observable in a consuming component, and then call these methods to push data in between each instance of each component. The best way to visualize this is basically just to set breakpoints everywhere where you're using this and step through it at runtime, which I'll do a little bit of as we get towards the end of this video. All right, so back in the mock data component class, it's yelling at me because I need to implement on destroy, so I'll go ahead and use IntelliSense to add that. I'll move that to the end of the class. And anytime you're working with observables, you need to be able to dispose of them when the components get torn down. So one quick and dirty way to do that is to just add an array of subscription objects, and then every time you subscribe to something, you can just push the return subscription into this array, and then in ng on destroy, you can just iterate over the subscriptions array and call dispose on all of them. So I'll just go ahead and do that real quick. So this.subscriptions.for each subscription unsubscribe. The isInitialized flag is to let us know that we're initializing the component because there's a state in the lifetime of the component where we don't actually want some of the subscriptions we're going to add to fire, and then we'll also add a flag to denote whether or not the switch page command came from a browser's navigation action, such as clicking the back button. All right, before I finish filling out this class, I'm going to go ahead over into the app routing module, where I have added the route for our mock data component, which is just going to be /mockdata. And I've also added this resolve object, which is the way that you involve the special resolver service in the navigation life cycle. So anytime we navigate to this route, the Angular framework will essentially call this service first, and that service will go off and look for data to make sure that some exists before it actually instantiates an instance of our mock data component. Okay, so back over here in our mock data component, to use the route resolver for this component, we'll just go ahead and add a subscription to this.route.data, which is this is the way that you subscribe to the resolver's response when it determines if there is actual data for the request or not. So once we get the response, we're going to go ahead and dig out that special header that we added by creating this xpagination key, and we'll json.parse response.mockdata.headers get the key. And that's going to be our page metadata, and we will use that page metadata to go ahead and populate the instance of our client-side version of our page metadata. Then we'll use some information from the query parameters and the body of the mock data response to call a function called onMockDataResponse, which I will paste in. And in that function, we will take our array of mock data objects, which don't have any type at this moment, and our page number, and set our mock data array. And I'll come back to the rest of this code in just a moment. The next thing we want to do is subscribe to changes in the query parameters so that we can figure out if the browser is actually needing to trigger an update of the pager control. which is where we want to use the is initialized flag, because we don't want this component to execute like the first time it actually renders itself after the route resolver passed our data set to us. So in the case we are initialized and the action did come from the browser, we want to go ahead and call get mock data, which I will add here. And get mock data is essentially going to use the same mock data service as the route resolver to call out and fetch for us another set of data. And just a quick note about the disposing of, or the unsubscribing from observables. There are some things you don't have to unsubscribe from, and I think the HTTP stuff is one of them, but it's a good practice just to go ahead and unsubscribe when you're using observable. It won't hurt anything if you don't actually need to do it. All right, so we need to add one more thing in ng on init, which is a subscription to our pagination API. So this is essentially subscribing to page changes from the actual pager control. Anytime you click on a page or hit next or back, it's actually going to push that selected page up to the hosting component, so the hosting component can go off and get a new set of data, or the whole next page set of data if it needs to. Okay, so now that this okay, so we finished stubbing out the mock data component, and I'll come back to this code as we continue to build out the rest of the components. So the next thing I'm going to do is go ahead and fill out the mock data display component, which is just going to be a simple display component. So I'm going to add an input parameter, which is just going to be an array of mock data objects. And I'm going to go over to the component template and add the HTML for a simple table, and it's just going to have a simple ng4 let item of items, and we'll render a row for each object in our mock data array. All right, and now that we've added that, we can actually come take our mock data display component, come back over into our mock data component, add this guy, and say items equals mock data, which is the array of mock data in our mock data component. Okay, so at this point I'm going to take a quick detour and go to the completed version just to talk about the concept for pager control for a moment. So basically what we're going to do is take the page metadata from the server and use that to stand up an object model that represents the pager control. And the object model is basically what I've called page chunks, an array of page chunks, and each page chunk has an array of pages in them, and each of those pages would have 10 or 20 or whatever the page size is within them. So once we've created that object model, we can then add functions to go forwards, go backwards. If we're at the beginning, we can go back to the end. If we're at the end, we can go back to the beginning. Each one of these items that represents these display objects, has the information in it that we need to go back to the server and get the next set of 10 items. Okay, so back over in the project, I went ahead and added the page chunk model, which is just going to have a index property, an isSelected property, and the pages array property. Okay, and since the pager component is a fair amount of code, I went ahead and filled out the entire component, and in just a moment I'm going to use the debugger to demonstrate what this code is doing. I suggest, if you're very interested in this, that you get the source code and take some time to step through it, because that's the best way to kind of learn the flow of a control like this. So of course in this component we're going to have a array of page objects, which is our pages display. We're going to have an array of page chunks, which we're going to use to manage figuring out what the next chunk of pages we have to display is in the paging control. Like when we go to the end here and go next, that's the next chunk of pages, and each one of these represents a new page. Okay, we also have a property for a selected page chunk, just so we know which page chunk we are currently on. We have a max pages per chunk, which is just set to 10 for the moment. Our page metadata is going to be realized via an input parameter, and we have properties here for showing X and 2X, which is just the text right here. And I actually just realized these need to be public, or you'll get an error when you build this for production. Let's see. Public. And speaking of public and private in TypeScript, most of the time I think you will see people not using the public access modifier, but I'm so used to doing it in C# that I haven't trained myself how not to do it in TypeScript yet. So that's really just your personal preference. The JavaScript that gets created always puts both public and private properties on the prototype of a constructor function, so it really makes no difference under the covers. It's just syntactic sugar that gives meaning to your code. All right, back over in Visual Studio, we'll just take a quick look at the template for the pagination component. It's basically just showing x to x of page metadata.total count. That is this area right here, and this, as you see my mouse going around this rectangle right here, that is the pager component, and this is the display for the data. So let's see. To create the pager effect here, we just have our previous and our next buttons. So those in this unordered list here, I have a list item for our previous button, a list item for my next button, and in between those guys is an ng4 let page of pages display, and that's going to render each one of these guys. Okay, so at this point I want to come back over to the browser and use the debugger to step through the full life cycle of this of the pagination app. So I'm going to go ahead and refresh the page, and the first thing that's going to happen is that we're going to hit the route resolver, and the route resolver is going to go ahead and make the request into our get mock data service on the client side, which is going to go out to the server and return the mock data response, which is the actual HTTP response. We see we have a status of 200, and we have in the response body a list of, or an array of the mock data objects. So since that returned okay, it will then vector us over into the subscription we had for this.route.data, which is how we use the route resolver. And we will go ahead and dig out the page metadata that we need to create our model for our pager control. All right, so we step into on mock data response, which calls our pagination service and vectors us into the to ng on init for our pagination component. The next thing we're going to do is initialize the control, which is going to set up all our page chunks, our selected page. Here we take the page metadata and we create page chunks. We basically get the total number of chunks. We get the size of the last chunk. We use the chunk total to create chunks of pages for each page chunk. Get off that. So at the end of this function, we're going to have this model that represents our page chunks and our pages, which I showed just a moment ago. Then we call get page chunk by page number, which is a function to get a page chunk by page index to help with properly initializing the component. And what that does is it looks through all the page chunks to find the one that contains the page with the matching page number. If the user refreshed or copy pasted the URL, then the hosting component will pass in the page index we are looking for to properly set the right page chunk. Next part of the call stack after we have initialized set the page chunk is set the selected page. So this basically passes in the selected page to display, which in this case is the first page of the first page chunk. So this code here is going to set the pages is selected property to true, which is going to cause the UI to have that particular page highlighted in blue. And we can come back over to our browser and see that everything initialized correctly, and we're on the first page of the first page chunk, and we are displaying our 10 items here. So again, since we're using a service to communicate between all these components, this hosting component, which hosts this display list of records and the pagination component, we're actually using that service to basically publish and subscribe messages back and forth between all the components. So if I click page 4, for example, we're going to go ahead and set the selected page. And then as part of this process, we're going to call the pager service to say next, and back in the mock data component, it has now received the next page for which it needs to go and fetch data for. So the pagination component has passed this page object into our mock data component, and the mock data component is going to construct the new request it needs to trigger the router to navigate to, let's see, page 4 with the page size of 10, and that will in turn invoke the route resolver, which will go fetch mock data again and reinitialize the component. And now we're on page 4. So the next thing we can do is take a look at what happens when you click next. So when you click next, what the code needs to do is basically get the selected page index and then get the next index by adding 1 to it, and then set the selected page by getting the page index of the next page's index. And here we see we're on 5, 6, 7, 6, 5, 4. Okay, so our pager control is working well. We can go next, previous, we can go to a particular page, we can navigate with the browser's buttons backwards and forwards, and that in itself updates the display of the pager control and the list of data. Right now, the way this is built, you can reuse this pager control anywhere you want to host some list of items and page back and forth between the information. But of course, there's always improvements you could do on things. So as I said, getting the source code and stepping through it and just messing around a little bit might open up some new ideas for improvements for this app. As I mentioned in the beginning, you can get the full source code for this off GitHub, HealerMedia /fullstackpaging. Thank you for watching.